Okay, we're going to do a video for CBE 4. Question 1. Solve the inequality. So, this second denominator is x times x minus 7. And these inequality questions are a little bit weird, but we're going to get a common denominator and then eliminate the denominators. So the left side needs an x, the middle one doesn't need anything, and the right needs both an x and an x minus 7, which is x squared minus 7x. So, excuse me, the numerators are 7x minus 9 is greater than or equal to negative x squared plus 7x. Okay, move everything to the left side. X squared, the 7x's cancel, minus 9 is greater than or equal to 0. And that is over x times x minus 7. The top factors, x minus 3, x plus 3, x minus 7, greater than or equal to 0. Everybody follow that? Okay. Now the question is, what does it look like? Well, if we were to graph it on our calculators, which we're not allowed to do, all we have to do is figure out when is the graph on the x-axis or above. Why on the x-axis? There's an equal to, right? It says greater than or equal to. So whatever this graph looks like, okay, some kind of something like that, we just want to know what chunks are on or above the x-axis. And the nice thing is we don't have to graph the entire equation. We do know a couple things about this that we'll call critical points. We know that x equals 3 and negative 3 are roots. Those are x-intercepts. We also know that x is not allowed to be 0 or 7, and both of those are vertical asymptotes. So we actually know a huge amount about the structure of the graph before we even start plugging numbers in. So I'm going to draw those. So I have a VA at 0 and another VA at 7. And then I have a root at negative 3 and another root at 3. Does everybody understand that? Now, one trick about VAs. The graph of a rational function will always approach the VAs in different directions unless that VA is a double VA. So is this a single or a double VA? Single. It only happens once. X. Is this a single or a double VA? Single. It only happens once. What does it mean to be a double? It would be squared. Okay? So if we just look at the vertical asymptotes, we either have this or this. Or sorry, you either have that, where it approaches from different sides, or you would have the opposite of that, which looks like this. Same is true of the other one. If you have a squared factor in the denominator, then if this is squared, then your VAs are going to look like that or like this. Does that make sense? Okay, a couple other things that are really important. The only place that we can switch from below the x-axis to above the x-axis, or vice versa, would be at the roots. These two spots are the only places we're allowed to puncture the x-axis. So, one way to figure out how to graph this is to plug in some number here, figure out is the answer above or below the x-axis, plug some number in here, figure out is the answer above or below the x-axis, a number here, a number here, and a number here. And that would work. And you don't even have to know what the answer is. You just have to know, is the answer positive or is the answer negative? So let's try a couple. It will. It will. So let's try -4. Any negative number beyond 4 would work, but 4 is the smallest negative number I can create. The smallest negative number? Whatever. You guys get what I mean. So it's a little bit hard to plug it into this equation. So I'm going to plug it into x squared minus 9 over x squared minus 7x. Okay, so we're going to plug in -4. I plug -4 in there and I get 16, and 16 minus 9 is 7, which is positive. I don't care what its value is. All I care is that it's positive or negative. Okay? What happens when I plug -4 in there? I get 16, and then -7 times -4 is positive, and a positive plus a positive is a positive. So what does that mean? It means the graph on the left side is above the x-axis. The only way to draw a line above the x-axis that satisfies that vertical asymptote is like this. And I don't care exactly where it is or what its shape is. All I care is it's above the x-axis and it has to max out at that vertical asymptote. Okay, now I need to plug a number in here. What's the easiest one? 0 won't work. -1. Why won't 0 work? That is the VA. So you're not allowed to plug these numbers in. You could, but it won't do you any good. Okay? It depends. If you plug one of those in and it's a root, the answer will be 0, which is neither positive nor negative. If you plug one in and it's VA, you're going to get divide by 0. So in both cases, it's useless information. All right, plug in -1. What is the sign of the numerator when I plug in -1? So we get 1 minus 9, which is negative. What is the sign of the denominator when I plug in -1? Positive. We get a positive plus a positive is a positive. So what is a negative number divided by a positive number? Negative. Oh, shoot. Sorry, guys. I wasn't paying attention. I'm good at doing that. That's not a vertical asymptote, right? This is a root. I drew that vertical line and freaked myself out. Okay, so it has to go something like this. Yeah, this is a root, not a vertical asymptote. But I know I'm positive over here and I'm negative over there. Okay? All right. Now let's plug in 1. 1 minus 9 is negative, and 1 minus 7 is negative. What is a negative over a negative? Positive. So this has to look like that. What's going to happen here? It's going to go through it. Then what's going to happen? It's got to approach the VA. How do I know it doesn't turn around and go the other way? It would need another root, and I don't have another root. Okay, do I need to plug anything in over here? No. That other side has to be positive because of the rules of VAs. So it turns out, if you have your roots and your VAs in the right position, you only need to test one number. And that one number will dictate where all the other points go. Okay, what do I mean by that? Yeah, they're all kind of connected in one way or another. Okay, so I have two roots, I have two VAs, both my VAs are singles, and I test this, and it's positive. Now I can draw all the other lines. So I have to come down, and then what happens? Go through, approach the VA to the bottom, so the left side would be, has to look like that, and then the right side would come down, it's got to go through, and after it goes through, it's got to approach back to 0, something like that. Okay? So, oh, I didn't answer the last question. So we'll go back to that one. So let's say this is -5, -4, 2, and 3. And I want to know, when is f of x less than 0? So I need to describe every interval where this graph is below the x-axis. So that would be this chunk, and this chunk, and this chunk. Okay? So how do I describe the left side? -infinity to -5. Okay? Infinity always gets a parenthesis. What about -5? It gets a parenthesis. Why? Look at the original equation. Am I allowed to count the x-axis? No. So this would be parenthesis union with, how would you describe the second one? -4 to -2. Oh, thank you. +2. So the left side, even though it's on the x-axis, I'm not allowed to count the x-axis. So that would be parenthesis, parenthesis, and then the last one, 3 to infinity. All right, let's go back. I should have done this before I erased everything. Okay. So for this one, I need to figure out when is the graph above or equal to the x-axis. So that would be this chunk, and this chunk. So the left side, -infinity to -3, and -3 gets a bracket. The original equation had an equal to, so if the graph is on the x-axis, it still counts. Okay, for this piece, we're going to, union with 0 to 3, parenthesis on the left because it's a VA, bracket on the right because it's a root and the x-axis counts, and then union that with 7 to infinity. Oh, they're both parentheses. Thank you. Does that help? Okay. All right. Graph the exponential function. So, notice the horizontal asymptote is -2. That automatically means that this is -2. Okay? So, y equals a raised to the x plus b minus 2. That's what I know so far. Okay? I'm going to redraw the axes like this so I can figure out what the pattern is. So this right here is a 1, this right here is a 2, and this right here is a 4. So if you go from a 4 to a 2 to a 1 to a 1/2, what's the pattern? 1/2. So I now know that A is 1/2. Okay? Now I just need to find B. And there is a really fast way to reason through it, and if you can do that, go ahead. The other way to do it is to just plug in an x and a y and use logarithms. So I'm going to plug in, I have a choice between 0, 1 or 1, 0. Would I rather put a 0 here or a 0 here? The 0 and the x is going to make things easier. They'll both work, but a 0 and the x will definitely make things easier. So I'm going to put 1 in there and 0 in there. 1 equals 1/2 to the b minus 2. Add 2. Hopefully you can just think through this. 1/2 to what power is 2? How do we take 1/2 and flip it upside down? The -1. So it turns out in this case b is -1, so you can just come up here and write x minus 1. Now what if you don't know how to do that? Well, you ln both sides, drop the b. The ln of 2 equals b ln of 1/2. Divide by the ln of 1/2. Stick that in your calculator, and you're going to get -1. What? Awesome. That is so good to know. Okay, shouldn't what be what? It should be 3. Well, that doesn't work. What did I did something wrong. Minus 2. The pattern is 1/2, right? Is it not 1/2? No, it should be. Oh, no, it's 1/3. Okay. Sorry. Dang it. All right. So to find your pattern, you have to redraw the axes. Okay. This is 1. That's 2. This is 3. No. No, that's right. It is 1/2. Okay, and the next time it touches right there, which is 8. Do you see how I've had to change my y-axis to make that work? Oh. Oh, I see what I did. This is -1. So anyway, it's 1 equals 1/2 to the x minus b minus 1. That was my mistake. So it is a 2. I just wrote a 2 when it should have been a 1. Okay, so Kylie asked a really good question. What if it goes the other direction? So what if my graph, let's go here. No, let's go here. Here. And here. So let's say that this is my equation right there. So I'm going to redraw my x-axis right here. Okay, and then from that x-axis I look at the pattern. This is a step of 1. Yes, before I was. I wrote a 2, but it was a 1. Yeah. Yeah, you just move, wherever it is, you move it. So 1, 2, 3. Okay, there we go. So my new x-axis is at +1. And let's look at the pattern. That is a gap of 1. This is a gap of 3. And this is a gap of 9. So what's the pattern? Times by 3. So I'm up here at plus 1. So y equals a to the x plus b plus 1. And I know that a is 3. So I just come in here and replace that with a 3. And then I pick a point, an original point, to plug it in. And we usually want to plug in the number where x is 0. So in this case, y equals 2 and x equals 0. So I stick those in. 2 equals 3 to the 0 plus b plus 1. I'm going to subtract 1. So 1 equals 3 to the b. What number for b makes a 3 into a 1? 0. So this would be a 0. And if you can't figure that out in your head, ln both sides, drop the b. We get ln1 equals b ln3. Divide by the ln of 3. Does that help? Okay. These look really complicated. All you have to do is manipulate them until they're as simple as possible. So I'm going to take the 5 and I'm going to stick it up on an exponent. What is the 5th root of something to the 5th? Whatever's inside. The 5th root and the 5th power cancel. So this cancels that. Okay. Now I have to check they're all base A. So the positive logarithms go in the numerator and the negative logarithm goes in the denominator. So log base A, on top we have j to the 5th, a to the 8th, and j to the 4th. Oh, that's a little tricky. J to the 4th over a to the 3rd. And then on bottom we have j to the 9th, a to the 6th. Well, the j's all cancel, right? I could put this over 1. So this, and that cancels. Okay? On top, what is a to the 8th over a to the 3rd? The top is a to the 5th. Right? So we end up with log base a of 1 over a. And a to what power is 1 over a? Right. How do we turn this into this using exponents? Would be the negative 1. Okay. If you wanted to convert that, you could say a to the x equals 1 over a. The only x value that makes that true is negative 1, so the whole answer is negative 1. Oh, yeah. All right, so negative 1 didn't work. Yay, I got one right. Okay. So this, you're just going to type in, I don't have base 4, so how do I type this into my calculator? You do ln 255 over the ln of 4, and your parentheses need to look like that. You could also use the log base 10 button. I just have a habit of always using the ln. That's a gimme there. Don't get that one wrong. Yeah. You guys know how to round, right? Go to the fourth decimal, look at the fifth one. If it's bigger than 5, make the fourth one higher. Okay. These problems look challenging, but they're actually really simple. So we need to convert this into some version of that and that. So first off, I have a square root. What is the exponential equivalent of the square root? What exponent does the square root? The 1/2. So this is really 5 to the 1/2. And that 1/2 can come out front. So 1/2 log base b of 5. Well, I don't have a 5. I have a 20 and I have a 4. Can I create 5 using 20 and 4? How? 20 divided by 4. So I'm going to turn this into 1/2 log base b of 20/4. But the rules of logarithms say if you have the logarithm of a number divided by a number, we can use the quotient rule and we can split it into 1/2 times log base b of 20 minus log base b of 4. Does everybody understand that? We're good? Now, it's just a substitution problem. You stick this in there, stick this in there, and don't round anything. Type those in your calculator, subtract them, and then multiply the whole thing by 1/2. Yes? Okay, so 1/45. Does it have an exponent? Does it have a root? Okay, so what if I had log base b of 1/5 to the 3rd? What would I do here? Well, I'd bump the 3 out front. So 3 times log base b of 1/5. I don't have a 1/5, but I can create one. 4 over 20. So this would be 3 times the log base b of 4 over 20. And then I use the quotient rule. 3 times log base b of 4 minus log base b of 20. So can you create that number that you told me? Okay. What if this was an 80? What would I do? Can I create an 80? 4 times 20. How would that change things? That would be 3 log base b of 4 plus log base b of 20, and make sure that both of those get hit by the 3. And I think those are the only combinations you're going to run into. Oh, so if you have something that looks like this, a 4, let me see. Okay, so like this would be a 3. Okay, well, don't forget that the square root or any root of 1 is always 1. So I can put this here, which means I can just do this. Right? Which means I can do this. What's the exponent? 1/3. And then I just drop the 1/3. So yeah, thanks for bringing that up. Don't forget that the square root of 1 is 1. And it doesn't matter what number you put there. It's always a 1. So if you have a fraction with a root in the bottom and the top is a 1, just put that same root on the top. Okay. Number 6. So when we have two logarithms added together, that becomes the ln of their product times this by 3. So I get the ln of 2x squared equals 12. Now what? What is the base? E. So I have e to the 12th is 2x squared. Okay. Divide by 2. And then I just take the square root. But anytime you're dealing with logarithms, if the original problem has a logarithm in it, then you need to check to see that your answers actually work. So I don't know what this is. E to the 12th, the square root of e to the 12th over 2. Well, let's just plug it in and see what we get. So we get the square root of e to the 12th divided by 2. Well, need an exponent in there. No, maybe. Oh my gosh. $201. So, if I plug in 201 here and here, am I okay? Yes, what am I looking for? A 0 on the bottom or a negative inside a logarithm. So I'm totally fine plugging 201 in there. Okay? Can I plug negative 201 in there? No, because you cannot take the logarithm of a negative number. It's like saying 4 to the x equals negative 7. How can you use exponents to turn a positive number into a negative number? It can't happen. All you can do is multiply or divide by 4s. There's no way to get a negative. So in that case, we have to throw out the negative version. Only the positive version applies. Okay. What are we going to do here? Cross multiply. So I get 14 times 9, and I get e to the 5x plus 16 times e to the negative 8x minus 11. If the bases of two numbers are the same and you multiply those numbers together, what do you do with the exponents? If I had x to the 5th times x to the 7th, I would take the 5 and the 7 and add them together to get 12. So, as long as the bases match, you can add the exponents. So on the left side, I get 126, and on the right side, I get e to negative 3x plus 5. What do we do from here? ln both sides, drop this. So the ln of 126 is negative 3x plus 5 times the ln of e. But the ln of e is 1. So then I just take the ln of 126, subtract the 5, and divide the negative 3. So this would be the exact solution, or you can plug it in your calculator and give the decimal approximation. We're doing on time. We're doing well. Okay. ln both sides. This one looks really hard, but it ends up working out kind of in a weird way. Drop the 2x, drop the 2x plus 1. So 2x times the ln of 32 equals 2x plus 1 times the ln of 64. Okay? One thing you could do is multiply that in, but that's going to be pretty messy, and you won't end up with an exact solution. So we need to get the logarithms together. So I'm going to divide by the ln of 32. And the ln of 64 divided by the ln of 32 is 1.2. Ooh. All right. 2x equals 2x plus 1 times 1.2. They don't want that. Oh, I thought it was going to work out. The 64 and 32, I thought they were going to simplify, but they didn't. All right. Actually, let's do this. So I do need to multiply that in, but because it says exact form, I don't want any decimals. So the left side is 2x ln 32. The right side is 2x ln 64 plus ln 64. Oh, I see what they want us to do. Okay, now what? If I divide it by 2x, this would cancel and this would cancel, but I'd get a 2x over there. Which, I mean, I guess technically you could make that work. I'm really interested to see how they check this one. I'm going to get my x's together. So I'm going to subtract this to the left side. 2x ln 32 minus 2x ln 64 plus the ln of 64. Oh, equals. Oh, geez, I just realized I could have done something else on the other side. That's fine. So now, I need to pull out a 2x. This and this both have a 2x in there. So 2x ln 32 minus the ln of 64 equals the ln of 64. So I'm going to divide by 2 ln 32 minus ln 64. And that cancel. That cannot be what they want, but we'll try it. Let's see what happens. Yeah. Let's see what happens when we do this. Do they even offer us an ln button? They don't. Okay. So, do you remember back when I had that decimal? Just turn it into a fraction. So we had 2x equals 2x plus 1 times 1.2. I was up late last night. 1.2 is just a fraction known as 6/5. So now multiply in 6/5. 2x equals 12x over 5 plus 6 over 5. Sorry, guys. Usually when they say exact answers, you end up having a logarithm in the answer. But I just got, anyway, I got all discombobulated. So I'm going to subtract 12x over 5. This turns into 10 fifths. 10 fifths minus 12 fifths is negative 2 fifths. Is equal to 6 fifths. I divide by negative 2 fifths, which means I times by negative 5 halves. And the answer, oh my gosh, is negative 3. Make sure you write negative 3 as an exact answer. Don't give a decimal approximate. Okay. So, bacteria grows according to PERT, unless they tell us otherwise. So, we start with 600. P equals, nope, Y equals PE to the RT. We start with 600. And what would that be? 8 hours later? So from here to here is 8 hours. So when we start with 600 and we grow for an unknown rate for 8 hours, we end up with 750 bacteria. Does everybody understand that? I need to solve for R to figure out what the growth rate is. So we divide by 600, ln both sides. And I get the ln of 750 over 600 equal to 8r ln E. But the ln of E is 1. So we divide this by 8. Okay. So the ln of 750 divided by 600, oops. And then divide that answer by 8, and I get 0.0278929,439. Now, logarithms and exponential equations are very, they get their feelings hurt. They're sensitive. If you round an interest rate, that can drastically affect your outcome. So I recommend doing second answer on these, or write it all down, because logarithms get their feelings hurt really easy. They're a lot like me, right? They go home and eat a jar of Ben and Jerry's and weep all night if you make fun of them. Okay. So now, when she comes back the next morning at 8 a.m., how many bacteria will there be? So this is my growth rate, 2.8%, and I want to know if I start at 600 at 8 a.m. and I come back the next day at 8 a.m., how many bacteria will there be? And why does it say round to the nearest whole number? Why don't we report 1,854.87? You can't have a partial bacteria. Even a little bacteria is one bacteria. Thank goodness. People in my family we're whole people. We might be little whole people, but we're whole people. So, I need to do 600 e to the 0.027, or sorry, 0.027, so on, times how many hours? 24 hours. And again, in your calculators, I recommend doing second answer. So 600 e to the answer times 24. And if if you're using a non-science, well, if you're using any calculator really, you should probably put parentheses around that, especially the calculators you guys are allowed to use. 1171.87, so I'm going to round that to 1172. All right, last one. So a Richter scale is used for measuring earthquakes. The energy E released is log E equals 4.4 plus 1.5 times M. What is the magnitude of an earthquake that releases that much energy? So I need to plug this in here. So we get log of 5.28. And how do those other calculators do this? Do you guys know how to do scientific? I guess you could just write it out. You could just write 5.28 times 10 to the 11th. And that is equal to 4.4 plus 1.5 m. Well, a second grader could, or well, probably a fourth grader could figure this out if they knew where the log button is. All we have to do is subtract 4.4 and divide by 1.5. And that will tell us the magnitude. So that problem looks nice and scary, but it's super easy. Okay, I'll get this online. I'll get the other video online. Please spend some time this weekend. Oh, jeez. Where are the magnets? They're over here. Spend some time this weekend studying the problems you don't understand. Tuesday, I better stop the video.